Hi there, it's Lori with a quick statistics refresher. Let's get started. In order to refresh ourselves, let's use our survey data from our class, and we're going to use just the first 40 responses so that when you go to do any work with this data yourself, you will get slightly different answers, and that's good. First of all, here's a worksheet that we could use to determine what kind of data we have. And it looks kind of hard. We've got nominal data, ordinal data, interval data, and ratio data. So let's take a look at what kind of data we have from our survey and how we might categorize it. First of all, what data comes only from names and there are no numbers? That would be nominal data. And that would be things like state, our favorite snacks, whether we're urban or rural, our gender, our major, and our own personal recipe for re-energizing. And all of those are just names, no numbers, and you can't rank pizza better than wings or anything like that. So it's not ordinal, it's just nominal data. Next, we'll look at ordinal data, and that is data that can be ranked. So the year born is ordinal, as well as the math skill expressed as a letter grade. Interval data is data that has equal spacing but an arbitrary zero. So are you tired in the afternoon question, where they're ranking things from 1 to 5, that's an arbitrary zero. A ranking of 5 is not twice as good as a ranking of 2.5. So it's in the order and they're equally apart. And again, math skill, if we converted it from a letter grade to a number, could also be that. Let's take a note here that social scientists often treat agreement scales as having a consistent distance between answers. There's an argument that they are not interval data, that they're just ordinal data, but we're going to treat them as interval data for our purposes. And then finally, we have ratio data, and that's data that has equal spacing and a meaningful zero. And in this case, we have two things that could do that or be treated as ratio data, and one is height. If you are 5 feet tall, you are twice as tall as somebody who is 2.5 feet tall. I'm hoping the 2.5-year-old is about 5 years old, or the 2.5-foot person is about 5 years old. Also, if your age, if you're 40 years old, you are twice as old as somebody who is 20 years old. So that is ratio data because it has equal spacing, and you can talk about it in relationship to each other. Finally, let's describe nominal data. How do we describe nominal data? Well, we can use both a frequency distribution and a proportion. A frequency distribution simply lays out the number of responses for each of the possible answers, and we're looking at a table here that does that. We can also express this as a bar chart, which is shown right here. This is a vertical bar chart. And notice that New York is where most of our respondents are from. Not a surprise. We can also do it as a horizontal bar chart, and we can even do a pie chart, which in this case is effective if the message you're trying to send is that most everybody is from New York, and that we have a variety of other states, but New York is the predominant one. Nominal data can also be expressed as a proportion, or in what is called a proportional representation, and that is where you want to express it as a percent of total respondents. So here we have our count of respondents by state, and then we can express that as a percent of total by simply taking the count and dividing it by the total, giving us 0.025 or 2.5%. We do that all the way down here. 77.5% of our people are from New York. We can then graph that or chart that, and we can see on a percentage scale here on the left that New York is by far the dominant state. How do we describe ordinal data if we're trying to represent it visually? Well, we can do a frequency distribution and we can do a proportion. The frequency distribution is one that we've just talked about, and that is, we've lost ourselves. Here we go. Here's our year born, and you can see we were born from 1957 through 1996. Most of our people were born in 1995. We can also do a proportional representation of math skill as a letter grade. The A, B, C, and D. About 60% of our respondents, first 40 respondents, consider themselves to have a skill level of about a B in math. Now, interval and ratio data can be expressed using both a frequency distribution, the proportionate frequency distribution, and also central tendency and variability. So some of the interval data that we're going to work with is, are you tired in the afternoon question, where they ranked it on a scale, do you love math, and if we converted the math skill to a number, we could treat it as interval data. Our ratio data, we would take our height and convert it to total inches from feet and inches, and age, we could convert it from year of birth to years of age by taking the current year and subtracting the age of birth. What is central tendency and variability? Let's take a step back and look at that real quickly. Central tendency is the measure of single values that have a tendency to be near the center of a distribution. It is a way to quickly describe or summarize interval and ratio data, and values we often use for central tendency are the mean, the median, and the mode. Let's talk about each one of those. The mean is the average of all of the scores. The median is the middle score, where half of the scores are above and half of the scores are below. And the mode is the most frequent score. And you can have more than one mode. You may have a bimodal or trimodal or multimodal. Examples using scores on I Love Math. Well, we had 7 people say they were a level 1 and a level 5 or 3, and about 14 said level 3. The mean of that is 2.9, the median is 3, and the mode is 3. Our cumulative responses are 7, and then we add that 6 in to get to 13, and we add the 14 to get to 27, 37, and we get to a 40. So that's a cumulative response. The line graph of I Love Math. Oh, let's go back and take a look at that. So we had 7 people give a 1, 6 people give a 2, and that's 100. If we add that all up, it's 116. If we divide that by 5, or I'm sorry, by 40, we get our 2.9. That's how you get your mean. Take your total scores and divide it by your grand total of respondents. If you have any questions about how to do the mean, median, and mode, let us know and we will get you some resources on that. But this should be a review for you. We can also do a line graph of I Love Math, and this shows that most people would agree or not disagree. They're neutral on the statement I love math, at least in our class. There is also variability that we need to look at with our central tendency and variability question, and it's the dispersion or spread of scores around the mean. It's how close or far are all the scores from the average scores, and we use 3 measures of that: the range, the variance, and the standard deviation. Let's go through those very quickly. The variance, we're going to do variance first, I guess. Yes. Yeah. Here we go. Range is the largest score minus the lowest score. So if your highest score is a 5 and your lowest score is a 1, then your range is a 4. You can also use things like quartiles and interquartile and percentiles. That's a topic that we can provide more on if you want. Just let us know. Variance is the average squared difference of the scores from the mean, and the standard deviation is the square root of that variance. So here is how we get the variance, or calculate the variance if we wanted to. Let's say these were our scores, and this is fake data, which we indicate in our title. So we have here all these different observations, and our mean is 19.77. What we first do is calculate the difference of the actual score minus the mean. And in this case, we get a negative 7.778. 15 minus 19 is negative 4, and on. Then you square that difference, you add it up, and you divide it by the sample size minus 1, and then that gives you and then you take the square root. So you add it all up, and the sum of the variance divided by the sample size minus 1 gives you the variance, and the standard deviation is equal to the square root of that variance. And just more slides on that. Let's look at our survey data for age in years. The central tendency of the age is the mean of 25.15, the median of 22, and the mode of 22. This tells us right here that we must have some outliers, some older people in the classroom that are pulling the mean away from the median and the mode. The dispersion of age in years, yep, we can see it right here as we lay it out in a frequency distribution with a chart, presentation of a vertical bar, and we can see that our mean is 25. Most of our scores are down here, so we must have some outliers up here that are pulling our mean out of the main area where most of our respondents are. These, as I just pointed out, these are our outliers. Interpreting standard deviation. Well, for normal distributions, 68% of the scores are within one standard deviation of your mean. If you go out 2 standard deviations on each side, you get 95% of all responses. And if you go out 3 standard deviations, you get 99% of all responses. It should be within that range. So let's take a look at how we do with that. Our variability around age and years, our standard deviation is 5.517. So if we take our mean of 25, then we add and subtract 5.517, I think it was. Yep, 5.517, and that should give us 2/3 of our scores. 67% roughly will be within one standard deviation of our mean, which was 25. If we do two standard deviations, that would be 25 minus roughly 11 and 25 plus 11, so 14 to 36. We do get a lot of our scores, maybe not 95%. And let's see about 3. Well, that takes us 3 standard deviations, takes us to from 7 to 42, and that is 90, not 90, that should be 99% of our scores. And it is not. We have some outliers here, which if we were doing research, we would probably drop those scores because they're not, it creates a non-normal distribution due to our outliers. So let's work through height in inches. Perhaps we're a little bit more normal in that regard. And we've got our central tendency. Our mean is 67.75, median is 68, and we have 2 modes, 65 and 68. Probably indicates that we have men and women in the class and that they might have a different mode for their height, possibly. It's a hypothesis. Our variability shows a range of 17 and a standard deviation of 4.16. Let's see that graph on a vertical bar chart. Our mean is at 67.7. Here are our 2 modes that we can see. And we've got some pretty tall people and we've got some pretty short people. But in general, we're spread out pretty well. And if we were to look at our standard deviation, within one standard deviation of 67.9, takes in about 2/3 of our responses. That looks about right. Let's see if going out 2 standard deviations does. This is 2 standard deviations. And yep, we've got almost all of our responses. And if we go out 3 standard deviations, which is the super big purple box, we've got all our responses. So check out the other help videos to see how to do all this in Excel using the data analysis toolpack. Central tendency and variability are pretty easy to do once you use the Excel products.